So, question number 2 considers K, where K is this parabola, and it's been fully drawn for you there. It looks as if the turning point is at 1, 1. But I'll just double check by completing the square. So x squared minus 2x, half of negative 2 is negative 1 squared is plus 1, then minus 1 plus 2, and that will give me x minus 1 all squared plus 1, and that is definitely a turning point at 1 and 1. This original function is a many to 1, so k of x is a many to 1 function, so its inverse will be a 1 to many relation. It will not be a function because each x will not have one y value. Okay, now I need to restrict the domain, but the way I need to restrict the domain is I need to restrict the domain to that interval. And there's only one answer for D, and it's got to be the smallest possible value of D. So, unlike the previous question where you could have chosen either side, I need to go from D to infinity. So I'm looking for this side. Now I could make D equal to 2, or D is equal to 3, because that would restrict it to a 1-to-1 function. However, it's got to be the smallest possible value, so D equals 1 is going to be my answer. So I might just clean that up off my screen. So D equals 1 is the answer. So unlike the previous question where I actually gave the new domain, the domain's been given to you where h is the new name of the function. It's got the same rule as k. K doesn't have a restricted domain, but h does. Okay, so I'm going to go from 1 to infinity. So this is going to be my graph for h of x. I'm going to call that h of x in red, and there's my endpoint at 1, 1. Looking for the rule, the domain, and the range. Well, the domain of h is square bracket 1 to infinity. The range of h is also 1 to infinity because it now starts at a height of 1. So the domain of the inverse equals the range of h, which is 1 to infinity, and the range of the inverse is equal to the domain of h, which is also 1 to infinity, and the rule. So I've got y equals x minus 1 squared plus 1. Swap them over, x equals y minus 1 squared plus 1. X minus 1 equals y minus 1 squared. Y minus 1 equals the plus or minus square root of x minus 1, which means the inverse of h is going to be 1. And since my range is 1 to infinity, it will be plus the square root of x minus 1. And there's the 3 answers for that part. And lastly, I need to draw a graph. So I've done my h of x in red. I'll now do my other one in purple. I need to find the intersection point. So I might go x minus 1 squared plus 1 equal to x, which means x minus 1 squared equals to x minus 1, x squared minus 2x plus 1 minus x plus 1 equals 0, x squared minus 3x plus 2 equals 0, and that's x minus 2, x minus 1 equals 0. Therefore, it should be at 1 and at 2. So 2 and 2 should also be an intersection point. Now to start this vertical, then I need to swing around, and it looks like when this was at 3, the x value was 2 and a bit. So that's going to be h inverse of x. And just to confirm that on a calculator, I might go edit clear all. Is fully in the way. Yep, and edit clear all. So I've got x squared minus 2x plus 2 minus 2x plus 2. I'm going to make that equal x and change my x's to y. And interactive advanced solve for y gives me those two answers, and I'm wanting this one, the positive square root. I take this back down again, I make that x, and I make that x. Now, when I look at my graph, if I take this, it's going to give me the whole graph. That's no good. So I'm going to put a restriction, keyboard, given x is bigger than or equal to 1. Now, when I open up my graph, if I drag everything with the restricted domain, it only draws it for the restricted domain. And if I pick up this one, that's its inverse. I have a closer look at all of that, and I do analysis, choose solve intersection point. There's the first one at 1, 1, tick, tick, and there's the second one at 2, 2. So that's the inverse questions.